This is the story of how one of climate change's biggest culprits could become one of sustainability's unexpected heroes. It's the story of concrete and a series of innovations inspired by the buildings of ancient Rome, the Dead Sea Scrolls, and the mysterious properties of human and animal bones, all of which have led to a remarkable and surprising innovation that could enable every new building to act as a temporary local store of electricity, and so could hold the key to the expansion of renewable energy. This episode is also the personal story of chemist and materials scientist Admir Masic, whose experience as a refugee has helped shape an initiative that could give rise to some of the great innovators and entrepreneurs of tomorrow.
You're listening to The Innovator's Journey, a podcast about the lives and careers of creative people, technology, and the future of work, with your host, Jonathan Winter.
Admir Masic, hello and welcome to The Innovator's Journey.
Thank you for having me.
So, to get started and to introduce yourself in a nutshell, how would you describe what you do and why it matters?
In a nutshell, okay, Admir is a chemist by training, working in a civil and environmental engineering department at MIT. And here I use my chemistry skills to tackle some of the biggest challenges that our society is facing in a quite near future, and it's the sustainability of materials, and specifically sustainability of construction materials, and even more specifically, sustainability of cementitious materials, so concrete.
And you mentioned, I think, that cementitious materials represent something like 8% of total global CO2 emissions?
Yeah, I mean, the number can be discussed for hours.
But it matters. It's big and
exactly.
It matters.
It's a significant contributor. So significant that really is one of the materials that are recently defined as bad materials, evil materials. And it's very wrong, I believe, to define it like it was defined, because it's a truly democratic material, and the numbers that come out, and yes, I agree with you, up to 8% of total CO2 emissions can be somehow associated with this material. But the numbers come out from the fact that every year we produce about 4 billion metric tons of this cement.
So it's not the worst material to produce from an environmental point of view, but the volume makes it a huge contributor.
So it's the volume and the need for an amount that we produce every year that then adds up to a big pile of CO2 emissions that we have to deal with.
Yeah, so this really matters. I'm looking forward to talking with you about the innovations that you're bringing about. But before we get to that, as you know, this podcast is called The Innovator's Journey. So I'd like to start with your personal and professional journey. Where does the Admir Masic story begin?
It starts in Bosnia and Herzegovina. I was born in ex-Yugoslavia at that time, that then split into many different countries. Unfortunately, the process of splitting was accompanied by war, and this definitely defined my story.
How old were you when war broke out?
It was just before I turned 15. And that year, 1992, I was forced with my family and a few personal things in my hands to leave my home and go to Croatia. We found refuge in Croatian city Slavonski Brod, that is just across the river where I lived in Bosnia, in Bosanski Brod.
Oh, really? So quite close to home.
Yeah, it was close enough that we really lived under the constant shelling and bombing and planes.
I guess that's something we can now imagine a little bit better with war in Europe again currently.
Unfortunately, yeah, what we are seeing in the Ukraine and the Middle East does reflect what I went through in these 4 months. But I must say only 4 months, because in July, we moved to Rijeka. Rijeka is the city where I lived for 4 years in a refugee camp, 7 kilometers from the city.
4 years in a refugee camp?
Yeah, 2 years in the refugee camp, and then 2 years after my family left me. So they moved to Germany in 94, and I stayed back in Croatia to finish my high school. And that's actually where the story starts.
Okay.
So
Is this where you first got an interest in chemistry?
Correct. So what happened is in September, we literally went to the city to search for a high school that would, take me so I could continue my education. And the first school we entered was kind of technical school for chemists, training people to go to work in a refinery.
And this was the first one you walked into?
Literally, first one.
Okay, right.
And that's when we realized that the Bosnian refugees were not allowed to go to school in Croatia. Mm-hmm. and so that was quite difficult for us because I was really good student. In Bosnia, I had all A's. And my mom, started to ask, what can we do? And it was really dramatic situation in the sense that my mother started to cry in front of one of these people in the school, and psychologists walked by and said, what's going on here? And this person just said, there is this mother and son, and she wants him to go to school, and she took us into her office, and then in a few hours I was offered to join the school as a guest.
They changed their mind.
Exactly. And that basically determined my future because I had to choose chemistry, basically.
So it's kind of a random career choice, but you studied hard. And did you enjoy it, this chemistry that you randomly chose?
So from a random choice to discovery of a talent. Within a year of going to this school, I realized that I'm quite good at solving chemistry problems. So good that the professor Željko Grgurić, who is the chemistry professor that noticed how good I was, suggested me to join city competitions, like little Olympiads in the city of Rijeka. And this is where I excelled. I literally won the first prize in this competition and was invited to join the summer school of best 20 chemists of entire Croatia. And so within a year, I literally became an chemistry genius.
So this gave you some confidence, I guess. Your family was in Germany by now, so you're by yourself.
Not yet.
No.
So this first year we were together, and honestly, there is not much to do in a refugee camp. You play ping pong and swim in the sea, or solve chemistry problems and do your homework. So that's what I did.
And so, I mean, this is obviously very vivid, this story is still vivid in your memory. What effect do you feel this had on you, and how has that sort of influenced your later career?
This is a good question. I think it just helped me to realize the importance of education. And so to invest in education, I think that's really something that I valued through entire my career. And I'm a professor now, and it's like culmination of this concept that you truly believe that what you learn is somehow your backbone of your life, okay? But also I realized that I had a talent. I found my talent, and important for me was to invest in that talent. And I think looking back to that time, I could have been a worker in a construction company, and I would not have discovered that I was talented.
And how did you know that was it obvious that it was important, or, because did you have role models for people who were investing quite so much in academic work?
No role models. It's just, things just were coming to me. I will tell you the why I'm saying this. It's really interesting. That first competition I joined, encouraged by my professor, there were like 10 questions that I literally had no idea about, never read about it, never learned about, never heard. But I did have some sort of general construction in my head how this would work. And this is what I did. I just wrote answers for 4 hours waiting for lunch. Lunch was important. I remember that. But I wrote my best guesses of what would be the solution for these 10 questions. And eventually, there were no second and third winner of that competition because I set a bar so high that with my number of points that
I don't think I've ever heard anybody quite so enthusiastic about an exam or a test.
And you see, through entire my career, I was just able to come up with ideas, with solutions that somehow were logical for me and would turn out that were not logical for many others. And a few of these, eventually led me to discoveries that I have made in my life.
Okay, so help me with the logic of your career then, because I don't yet see it. Because you did a PhD in Turin, in Italy, and at that point you had discovered another interest, which was ancient materials. So what is it that led to this interest in ancient materials?
So what happened is that I met a wonderful course mate, like a university mate, and he is the third generation of restorers in Italy. So imagine having one of the biggest Italian restoration companies. His dad and his grandpa started that. And spending time with him, Marco Nicola and Nicola family restorers, kind of brought me into this ancient material space.
So when did you first make the link between studying the materials of ancient civilizations and your current interest in modern materials and sustainability? Because the link isn't obvious to me.
It's not obvious again. Nothing is obvious in my life. Things just happen. I started a company with Marco Adamanzio SRL. It's actually still operating, which is kind of nice. But in the meantime, I decided to move from Italy to Germany for several reasons. And I sold my shares to Marco and then moved to Germany. And there I found a job in the Max Planck Institute in the biomaterials department to study collagen. And because parchments are made out of skin, and skin is collagen, and therefore that's how I basically suggested to Peter Fratzel, who is director of this department, biomaterials department, that there is a lot that we need to learn about collagen interacting with water, and that understanding of hydration of collagen might inform us on many properties in different contexts: biological, biomedical, biomaterial context. And so I started to really focus on hydration properties of collagen and continued working on the ancient manuscripts through a project with the Ira Rabin on Dead Sea Scrolls. So I was privileged to put my hands to some of the most valuable manuscripts in the world. So that really gave me a lot of satisfaction. And in the meantime, I really built a knowledge on how biological materials work, both soft collagen, keratin, silk, but also mineralized collagen. And that's the connection now.
I was waiting for the connection between skin and concrete.
Bone is the connection, because bone is the load-bearing material like concrete.
Yeah.
And the bone structure is a multifunctional structure. So from a molecular level up to the macroscopic scale, mineralized collagen and bone kind of is a multifunctional material by definition.
Right.
It's load-bearing, but it has self-healing. It has components of some structure. Like there are even features that we don't know what they are for, but still are compromising on load-bearing capacity, but contributing to maybe energy storage and things like that.
Right. And I guess the ability to transfer ideas from one area to another is really a key feature of innovation, isn't it?
Absolutely. And working in the interdisciplinary kind of space is something that I think creates a lot of potential for discovery. Yeah. Just to conclude this concept of connections, this is exactly why we think that multifunctional concrete could be the solution for a sustainable future of concrete. And it comes from the bone biological multifunctionality of bones. We ask ourselves, can we expand the functions of concrete that are not just the load-bearing kind of functions, but are also that they incorporate self-healing or energy storage,
Right.
and so
Yeah.
on.
So it's a form of biomimicry, I guess you could say.
Correct.
Now, you eventually ended up at MIT a few years later,
Yeah, 2015, 16.
and now you're an associate professor
And now I'm an associate professor, and
with a company and a lab and a team.
The lab is the key here at MIT, and we produce innovation and we produce results, papers, and then some of these innovations are translated into real world.
And could you have imagined as a 14, 15-year-old ending up as leading a team in a lab at MIT? It must have been beyond what you could imagine.
That's for sure. I couldn't imagine much in my refugee camp. But again, I think what I did have, there were dreams to, tackle biggest challenges.
So as you look back at your career so far, how do you make sense of it? I mean, I'm interested in the way careers develop. What's the meaning of your career so far?
I mean, I'm blessed that I discovered something that I have intrinsic talent for, I think. And what I did in my career is invest in that systematically. Like, really be sure that these skills are nurtured. Okay, and I think nurturing talent is something that defines my career. And I think for everyone out there, it's very important to find what comes to you naturally, what really you think you are good at. It's not just being good at, it's that things come, you enjoy.
So there's a kind of, some people call it flow, don't they?
Correct. I think this is kind of a resonance between your physical and mental and what is required from the outside. And once you enter into this resonance, then you really are able to oscillate and reach heights that are somehow quite difficult if you are not in resonance.
Yeah, that's a great description. And you've become so passionate about it that you're trying to help other people with an experience of being displaced to achieve that. I know you've founded an organization called MIT React, and you have a new emerging talent program. Tell me what inspired that and what that does.
Yeah, it is something that gives me a lot of satisfaction simply because I see individuals move from the space of desperation into a space of excellence. Just because we help to create opportunities for highly talented individuals to emerge from the noise, from the background they live in.
Identifying and selecting people to be part of this program and providing them with educational resources, how does it work?
I was asked by my colleague here, Sanjay Sarma, to come up with ingredients that would be ideal for me as a former refugee to be able to emerge from a refugee camp and become an MIT professor without being lucky like I am, okay? So make it more systematic and with less obstacles. And that's how we came up with, together with Hala Fadel and others, we came up with these 3 pillars. And pillars are solid online certified content. Second component is this entrepreneurial component that is more a psychological component to say, listen, you can do it. You need to systematically approach it with the skills that we know more or less what is needed to go from an idea to a business pitch and then start up and things like that. And then third component, that's a very important component, are the paid internships. So gain experience, show your skills to an employer, potential employer, but most importantly, earn some money to survive. to be able be
Yeah.
sustainable and bet on education in a sustainable manner. So those are three pillars.
Great. And the subject matter, is it computer science and data science, or is it broader than that?
We are currently exploring many others, but it started as a computer and data science because you can code and program anywhere in the world.
Yeah, flexible, valuable, portable
Exactly.
skills. Yeah,
Exactly.
yeah. And you've had several hundred people go through the program so far from many countries.
So far, several hundred of extremely talented individuals went through the program, scoring in average A's at MIT courses online, and then securing high level jobs in big companies. And the program now moved under the umbrella of Jamil World Educational Lab, JWEL, here at MIT in open learning, and we will use this model to offer opportunities for underserved communities around the world.
It's just so impressive to hear of that, and wonderful story. I will provide a link in the podcast so people can explore that a little bit more.
Sounds good, yes.
Admir, thank you so much for telling us about your personal and professional journey. Before we talk about your innovation that we've hinted at, I asked you to think of an artefact that represents your creative journey. Have you chosen something?
Yeah, it's an artifact. It's a book written by a Roman scholar called Vitruvius, and it's De Architectura, collecting all these recipes, including ancient Roman concrete that we will discuss in a minute. And it somehow also inspired my work on this antiquity-inspired, not bio-inspired, but antiquity-inspired work. And I truly believe that there might be clues in this ancient wisdom that might help us in transitioning to a sustainable future.
No, what a great choice. Thank you. I think it's the first book we've had as a creative artifact on the podcast, so I really like that. We'll be back shortly to talk about the work you're doing now and your vision for how work itself is changing.
You're listening to The Innovator's Journey, a podcast about the lives and careers of creative people, technology, and the future of work, with your host, Jonathan Winter.
Admir Masic, the innovation we're featuring today is your work on the sustainability of cement and concrete and some of the amazing innovations that you and your team have been working on, particularly the idea of concrete as a battery or supercapacitor. So it's a big problem. You described that at the start of our discussion, 8% of global CO2 emissions or something like that. So what are the solutions?
When I kind of decided to tackle this, to be honest, I thought it would have been easier than what eventually has been. But
that's confidence.
Overconfidence, maybe. The challenge is quite big, and there is a fundamental reason for that. We have a material that is processed at very high temperatures, and during this process of calcining clay and limestone, you emit, by definition, certain amount of CO2 that is associated with the limestone. Limestone is calcium carbonate. And because then cement goes through hydration chemistry and not carbonation chemistry, that CO2 that was associated with limestone in theory never comes back into your concrete block. That CO2 is now in the air and is not cycling back in theory, apart through slow carbonation over decades. Concrete, of course, is a combination of cement and aggregate, gravel and sand that in general are inert aggregates, to then allow cement to go from slurry into stone and solidify all those big chunks into one solid unit, and that's our concrete block.
Okay, so the first solution is to substitute cement with some other materials within the concrete structure.
So we can reduce cement content up to 40% with substitution with some other materials that are not clinker. For example, a fly ash. But the availability of these things will definitely reduce in the future. Finding, for example, electrifying is a great idea, using kilns that are run through renewable electrical energy. And
so at least then the heat required is theoretically cleaner in the future if the energy is renewable.
But still, compensating for those CO2 emitted from limestone has to be some sort of a carbon capture strategy or some sort of eliminating completely having not limestone as a source of calcium. And so it's challenging. It's really, especially cost, when it comes to cost. And think of ending up with a material that is competitive also from the cost is very difficult.
Yeah. So whatever the solution, because it's so widespread, the production of cement and concrete, the solution has to be implemented by so many different organizations around the world. And that's really only going to happen if there are economic incentives to do so.
Yeah, I believe truly, and here in CS Hub, we think that the future is a multifunctional concrete. Still based on backbone of ordinary Portland cement, but the concrete itself should have additional functionalities, not only load-bearing, but also maybe carbon capture and storage, maybe self-healing function that will allow this material to last longer, and systematically avoid emissions through a lifetime.
So the concept here, the innovation, is actually about multifunctional concrete. Which of these functions have already been developed, and have any of them been deployed at significant scale?
In our lab, we looked into ancient Roman concrete, self-healing functionality, and we translated it into a modern self-healing concrete that is sold by a startup. And if you want to buy self-healing Roman-inspired concrete and build something with it, you should contact DMAT.
That's the company you founded.
Correct. I mean, we are still at the startup kind of stage, but holds a great promise because it allows life extension by 50%.
That's a fascinating idea to extend the life by that much, and also obviously for safety critical applications. I imagine that's something that's popular.
Yeah, I mean, we would like to build using self-healing concrete. Current self-healing concretes are quite expensive, and what DMAT is able to offer is self-healing concrete with an extremely competitive price.
Great. Sounds good. I'll provide a link on the podcast again for people who are interested to go into a little bit more detail. I found it fascinating reading about self-healing concrete and its inspiration in Roman concrete, actually. It's a great story. So let's get on to this other application of concrete, which is around the supercapacitors.
Yeah, probably the one that will make this material the material of the future instead of material of the past. in a sense that if you think that, let's talk about the house. You make a foundation that is made of concrete, and that foundation serves to hold your house. But now imagine that in the foundation, this block turns into a battery for your solar panel that you put on the roof and allows you to store energy during the day, like now, and use it the next 12 hours.
And is the volume of concrete from your experiments, is that sufficient to store enough to be useful?
So it looks like we are there, okay? Carbon-based cement composite supercapacitor has a low energy density. That's the drawback of the.
Well, it's like 100 times lower or 1,000 times lower.
Yeah, we are talking about orders of magnitude.
Yeah, but there are still useful applications, one of which you've just described. So it's the foundations of a house can hold enough energy to serve that household for one day or something like that, is it?
Correct.
And won't consume any rare earth materials in the making?
No, that's exactly why we are excited about this discovery.
Carbon black, I think you said, was the addition.
Carbon black is the addition where 3-4% is enough to create this nano wiring of carbon black. So carbon black particles are touching each other and creating the nanowire that eventually makes cement and concrete conductive material. And then you can build a electrode of a supercapacitor, and this electrode that then you put in series or in parallel, and that it will allow you to store renewable energy. And so imagine now that we build a road that comes with solar panel farms and wind turbines around, and that charge then is sent to your electric car and you don't consume, let's say, any fuel. You just are constantly charging your electric vehicles. And
That would be nice. Yeah, I mean, here in the UK, we have a real problem with charging capacity. So
yeah,
we may have to
well,
wait about 50 years to rebuild the roads, but I can imagine that in the future.
innovation will definitely take some time to move into real world, but we are very optimistic simply because probably this is the first time that I can see, transition from non-renewable energy to renewable energy, because this energy storage is the bottleneck here. And coming up with a bulk energy storage solution that is scalable, and it's most importantly inexpensive. It doesn't require rare elements and metals. And I mean, I could imagine the next 5 years, 10 years, some high-end applications of this material.
Is it easy to manufacture? I mean, how technical is it? Can you do it on site?
Honestly, Jonathan, I could train you in a day to make it, and you could build your home supercapacitor. At least make a material that would be able to fulfill requirements of supercapacitor energy storage.
And presumably the business model is also an area where we need a lot of innovation. We're going to have carbon taxes, carbon credits. These things are going to be part of some of the business models for the future.
That's for sure. I mean, once it arrives, carbon tax of cement will definitely push us to develop new business models there.
Because it's going to increase the price of cement.
Correct. And price will go from extremely inexpensive to quite expensive if the tax is applied, and alternative solutions might start to be competitive when it comes to the price.
Wow. Well, I can just imagine a future now full of this local storage of energy, which could make a huge difference to the world. Thank you. The final part of our conversation is about the future of work. Now, I'm not really sure whether I'm talking to you as an academic chemist or a material scientist or as a civil and environmental engineer.
Even an open learning kind of guy.
Yes, exactly. Even an open learning guy educating refugees around the world online.
Yeah.
But as you look at the future, if we think, say, I mean, with the pace of change socially and technologically, if you look 5 or 10 years ahead, how do you imagine we will be working differently in any of those areas?
I think we all need to realize the challenge of climate change is the real threat for our society. And I think a lot of people will need to put the best of their skills to tackle this challenge and solve it. It's not an easy task. And I think a lot of new jobs will navigate around sustainability. And that, includes many different facets, from producing of sustainable energy to recycling to sustainable materials. So sustainability, I think, is a new avenue of new jobs, and will be required simply because the effects of climate change will hit us so hard, unfortunately, that we will need to really behave like in a COVID-19. Everyone came together to tackle this challenge, and it was beautiful to see us pushed to the limit. And I think the same might happen with sustainability. We will need really to focus, because we'll end up not securing the future to our children. I mean, I have this little boy, and I wish him the best, and I hope I will guarantee him the best of the future. But looking at trends, I mean, he might not get a future if we continue with the common practice we have right now.
So my final question then, or final 2 questions, is, first of all, if you were giving wise advice to young Admir, what would you say?
Believe in education and find a way to learn in every moment. Everything you do, try to get better and learn. And I'm saying it because I experienced it through React program. there is a process of trust and respect that you build with your course mates, people that you share this educational path. And these connections are really special. And then when you put at the table educated people, I think magic happens, and it's a foundation for peace building, for innovation, for every aspect of your life. I think becomes better, and that's what I always recommend. Like, just enjoy learning and make sure to bet on education.
Your description is so human and so creative and inspiring, and yet we're hearing about technology constantly, and AI especially, and how much we're going to find the work we do is substituted by AI. What is it that is going to be uniquely human left for us to do?
AI will definitely revolutionize how we work, how we live, how we interact, and also what we know. Nevertheless, I think chemistry that happens in a classroom will be difficult to substitute with AI. It's more about human interaction and connections that you make in your brain that will last. Again, it's like knowing how to do math and using the calculator, okay? I mean, calculator is a great thing. But what you have in your brain and how these connections are made and how emotions are built around the concept, I think will be difficult to substitute through machine learning.
Well, Admir Masic, thank you so much for sharing your story, your innovation, and your vision for the future for all of us. It's been a pleasure.
Thank you for having me. It's been a great pleasure.
Thank you for listening to The Innovator's Journey with me, Jonathan Winter. If you enjoyed today's story, do share it with your friends and colleagues and subscribe to make sure you hear future episodes. This podcast was recorded in Riverside, edited and transcribed automatically in Descript, with algorithmic music from SoundDraw and artwork generated with DALL-E. The rest was human.